So what we're going to start off with is looking at what the value of the base does in a logarithmic function. So every logarithmic graph of the form y equals log base b of x, meaning that there is no value out in front, but the b all has to go through 0, because log base b of 1 is equal to 0. Any base to the power of 0 is going to be equal to 1. So that point has to be on the graph. What we have here is we have the graph of log base 3 of x. The graph passes through the point 3 and 1 because log base 3 of 3 is equal to 1. So it says, in each of the following, complete the statement and sketch the graph on the grid. Use a graphing calculator with the following window format. So what I would like you to do is graph these 3 graphs. But when we go to put them into our calculator, can I put log base 10 of x in my calculator? How would I write that in? Actually, let's not start with that one. Let's start with this one. How would I put log base 3 of x into my calculator? Log x divided by log 3. That's how I would put it into my calculator. So how would I put log base 10 of x into my calculator?
Log x divided by log 10? Or is it just
Wouldn't
log
it-
x?
Yeah.
It could be just log x because the base is equal to 10. So then what about log base 1/3 of x? How would I use my change of base to put that into my calculator?
Log x over log 1/3.
Yes. And then log 1/10, or log base 1/10 of x would become log x over log 1/10. So this is what I would like you to complete for me, is drawing these 3 graphs and then telling me what point they pass through in order to intersect at 1. So if you have to, what you could do is you could let y equal 1 and then find the intersection point for each of these graphs so that you know where it intersects the graph. And then try to see if you can do part B. And part B is not using the graphing calculator. Looking back on lesson 8, what I had asked you to do the other day was to graph these 3 log equations onto the same grid so that we could see what the effect of the base, what does the base do to the logarithm. So log base, or log base 10 of x, that graph should look like that. So it should be below log base 3x, correct? Okay? So this was my log base, or just log x. And then when I graph the log 1/3 x, what do you notice about that graph? How would you describe the log base 1/3 of x?
It like curves the other way. Starts
Curves
with
the other way? If I went like this,
Is it a reflection?
flip. Is that kind of what it looks like? There's my log 1/3. And then my log 1/10, log base 1/10 of x. again, looks like a reflection of which graph?
Log x.
Log x. So then if I had to graph log base 5 of x without using the calculator, where would I put it?
Log base 1/5 of x.
Pardon me?
Would be log base 1/5 of x. Is it the
No, where would I graph this? How would I draw this?
reflection of the x-axis? I don't know. I don't know what you mean by.
Okay, how would I sketch the graph to this using what I know? So first of all, does the graph, is it going to go like this or is it going to go like this? It's going to rise. Okay, so it's going to be a rising graph. And what do I know about the bases of these two? One was 10 and the other one was 3. So where's 5 going to fit in? In between. Not necessarily right in the middle, not necessarily closer to 3, but it's going to be somewhere in between. And it is also going to go through this point at 1. And then what about the log base 1/5? It would be the reflection of the line that I just drew in green. So it's also going to go through this point of 1 and 0, and it'll be between these two graphs. So then we're going to look at the table. What is the domain for all of these graphs? Or actually, first question, do all of the graphs have the same domain? Yes, and what is that domain? What are my possible x values?
This is greater than 0.
Okay, is it equal to 0 or just greater than 0?
Just great.
Just greater.
Just greater, because it's showing that it's approaching that line. So x is greater than 0, and it's a real number. And basically, it's the same for all of them. What is my range for all of these? Y can be any real number. And it's the same for every graph, even the graph log b of x. Where do all of these graphs intersect the x-axis?
At 1 and 0.
At 1 and 0. So the x-intercept is 1. Where do these graphs cross the y-axis? They don't. So is there a y-intercept? No. The asymptote. What is the imaginary line that the graph does not cross?
X equals 0.
X equals 0, the y-axis. And then the last one says, what is the value of x when the value of y is equal to 1? So how can I figure out the answer to this? Pardon me?
Change y to 1 and for example 1 times 1 is equal to 3 to the power of 1.
So if I have 1 equals log base 3 of x, to solve that now, I can rewrite that into exponential equation, or into an exponential form. So base 3 to the power of 1 equals x, and what would x equal? 3. If I change this to a 10, 10 to the power of 1 equals 10. Change the base to a 1/3, and I get 1/3 to the power of 1 equals
1/3.
1/3. If the base is 1/10, the x value would be 1/10. And if the base is b, When y is equal to 1, the value of x would equal b. So how do the graphs of log base 3 of x and log base 1/3 of x compare to each other?
They're a reflection of each other.
They're a reflection of each other. And a reflection in which axis?
Why? Oh, in the x-axis.
In the x-axis. So it's a reflection in the x-axis. What about the graphs log base 10 of x and log base 1/10 of x?
Same thing.
Same thing, a reflection in the x-axis. So if I wanted to complete the following statement, the graph of y equals log base 1/b of x is a blank of the graph of y equals log b of x. What would I put in here? What's the relationship between the two graphs?
It's a reflection.
Okay. And it's a reflection in which axis?
X-axis.
In the x-axis. Good. So it says in the transformation unit, the replacement for the reflection in the x-axis was replacing y with a negative y. So we're going to use this idea of a replacement to show y, or to determine the equation of the graph reflected in the x-axis. So I have that y equals log base b of x. According to my rules, if I reflect something in the x-axis, I have to replace y with a negative y. So then this becomes negative y equals log base b of x, and that's replacing y with a negative y. But I wouldn't leave it in the form of negative y equals. I would write it as y equals. So in order to write it as y equals, what do I do with the negative? Move it to the other side. So what I have is I have this equation, y equals negative log base b of x. But we've already said that this equation here, this log 1/b of x, is also a reflection in the x-axis. So what that means is that this equation, negative log b of x, is the same as writing the equation log 1/b of x, which means log base 1/3 of x is the same as negative log 3 of x. So in class example number 1, it says if log base 4 of x equals 8, what would be the value of log base 4 of x? Well, log base 1/4 of x is the same as negative log base 4 of x. And what is log base 4 of x? 8. So this would equal negative 8. It says prove the result in A by converting to exponential form. So if I have log base 4 of x equals 8, how would I write that as an exponent? Four to the power of 8 equals, okay. If I take the other log base 1/4 of x, in order to write it into exponential form, I have to let it equal some value. So then how would I put this into exponential form?
1/4 to the power of 3 equals.
Okay? I don't have the same bases yet. So how would I change the 1/4 to a base of 4? What would I need to do?
Make it as power of -1.
These are reciprocals of each other. So what happens to the exponent?
That's negative.
The exponent becomes a negative. So I get 4 to the power of negative b equals x. And what I have right here is I have that x has to equal 4 to the power of 8, which means 4 to the power of negative b has to equal 4 to the power of 8, because the x's are the same. So now I can let the exponents be equal to each other. Negative b equals 8, and then I have b equals negative 8. So it's just another way of writing the expression. Following page, we look at 3 graphs: log base 2 of x, log base 4 of x, and log base 8 of x. It says, complete the following statement. Log base 2 of x passes through the point of 8 and what? So if I follow over to x being 8, where does it cross? Or what's the y value when x is 8? 3. In the graph, log base 4 of x, when x is equal to 8, what is it equal to? What's the y value this time?
3/2.
3/2. And log base 8 of 8, when it passes through 8, the y value is
1.
1. So the graph of y equals log base 4 of x is a vertical stretch of the log base 2 of x. And the question is, what is the stretch factor? So, in other words, what can I multiply by 3 to get to 3/2? 1/2. 3 times what equals 3/2? So it would be x equals 3/2 divided by 3, and I would get 1/2 for an answer. So this is a stretch factor of 1/2. It says the graph of log base 8 is a vertical stretch of log base 2. What would I multiply by 3 to get to 1? Pardon? 1/3. And here's something to look at. 8 to the power of 1/3 equals 2. 4 to the power of 1/3 equals 2. Or sorry, 4 to the power of 1/2 equals 2. So if I had the graph log base 2 of x and log base 64 of x, and I wanted to say that log base 64 was a stretch, what would be my stretch factor? So what I'm asking is 64 to what power is equal to 2?
Is it going to be
I don't know, you tell me.
1/6?
And how did you get 1/6? Did you guess and check it?
Well, I figured out what 2 to the power of what is 64, then I just put 1 over that.
So 2 to the power of 6 is 64. So then 64 to the power of 1/6 would be 2. So it ends up being a reciprocal. So log base 64 of x would be equal to 1/6 of log base 2 of x. So if we look at class example, or sorry, at the note or the general rule, it says the transformation which maps y equals log base b of x to y equals log base b to the power of n of x. So if we think 64 is 2 to the power of 6, up above 8 was 2 to the power of 3, 4 was 2 to the power of 2, is a vertical stretch about the x-axis by a factor of 1 over n, which means I could rewrite this expression, b to the power of n of x, as being 1 over n of the log base b, which is really wordy and doesn't make a lot of sense until you start using it in the question. So if I have log base 3 of x, and I want to transform it to the graph of log base 81 of x. What I want to determine is 3 to what power is equal to 81? 4. So then this would become a vertical stretch about the x-axis by a factor of what value? Is it a stretch by a factor of 4 or a stretch by a factor of 1/4? 1/4. Which means log base 81 of x would be equal to 1/4 of log base 3 of x. So if I look at number 2, what exponent would 4 need in order to go to 16? 2. So 4 squared would equal 16. So then what I have is a vertical stretch about the x-axis by a factor of how much?
2.
Oh, we went why 2 this time and not 1/2?
Because flipped it, so like you're trying to find it. Gave you the bigger one first. And so.
Right. So if I'm going from the bigger one to the smaller one, it's the factor of 2. If I'm going from the smaller to the bigger one, it then becomes the reciprocal. So then log base 4 of x would be 2 times the value of log base 16 of x. The other way that I can look at it too is I can take this log base 81 and write it as 3 to the power of 4 of x. And then that 4, when I bring it out in front, becomes 1/4 log base 3 of x. With this one, I would need to take this 4, just a second, log base 1. So it would be 16 to the power of 1/2, because that's how I would get to 4. And then I bring the 1/2 to the outside. So it's how would I start from here to get to there? How would I start from 3 to get to 81? How would I start with 16 to get to 4? And then that gives me the exponent here, which then I can bring out in front. So if log base 5 of x is equal to 6, what is log base 125 of x? So there's two ways that I can solve this question. The first way that I can solve this question is actually in part B. I could convert this to exponents, which you might actually find easier. 5 to the power of 6 equals x. And then I have, with this log base 125 of x, I let that be equal to the power of v. So then I have 125 to the power of v equals x. In order to make a comparison, I need to have a common base. So how do I write 125 as a base of 5? 5 to what power equals 125? 3. So I get 5 to the power of 3v is equal to x. So that means that the x's are equal. So then 5 to the power of 6 has to be equal to 5 to the power of 3v. And what does v equal? 2. So then v equals 2, which means log base 125 of x would equal 2. So that's using exponents. If we use stretch factors, what we do is take this 125 and write it as a power of 5. So log base 125 of x becomes log base 5 cubed of x. And when I bring that 3 out in front, what does it become? 1/3. So now I've got 1/3 log base 5 of x. And what do I know about log base 5 of x? 6. It's equal to 6. And what is 1/3 of 6? 2. Same answer. Okay, so I'm going to give you a couple of minutes. I want you to work on questions 1, 2, and 5. So we're going to do some further transformation with logs. So if you remember from chapter 1, we would start off with y equals f of x. And then we would do a series of transformations that led us to a graph that could look like this. Y equals a times f of b times x minus h plus k. In this graph, what was the responsibility of h?
We move the graph left or right.
Okay, what did k do?
Up or down?
And the value of a?
Stretch factor.
Vertical stretch factor. And what was the factor by?
1 over
Not 1 over a. It was 1 over a when it was on this side.
Oh,
So it'd be a. And then what was b?
1 over.
1 over b. And what kind of a stretch factor was that?
Horizontal.
Horizontal. And if the values of a and b were negative, what did that do to the graph? Reflection. Okay. So what we're going to do is we're going to use these letters A, B, H, and K on our log graph. But when we're talking about our log graph, because our base could be anything, we're going to use C to represent that base, just so that we don't get the base B confused with the horizontal stretch B. Okay? So the graph of y equals log base 3 of x is shown. Question A asks you to write the transformation associated with each of the following and then sketch what the graph would look like on the grid. So if I have the graph y equals 2 times log base 3 of x, what was my replacement? Where was that 2 originally?
The other side of the y.
On the other side with the y. So it was replacing y with a 1/2 y. So what kind of transformation does this result in?
Vertical stretch.
Vertical stretch about which axis?
X-axis.
And what's the factor?
2.
Which coordinates are impacted, the x's or the y's?
Y.
The y coordinates. So what I would do is I would take this graph and I would stretch the y coordinates by a factor of 2. So if I take this point, the y coordinate is 0. When I stretch it by 2, I still get 0. This point right here, which is when x is equal to 3, the value of y is 1. When I stretch it by a factor of 2, it goes up to 2. Then I've got this point here when x is equal to 9. The y value is equal to 2. When I stretch it, I get a y value of 4. So my graph would look something like this. That would be my graph of y equals 2 times log base 3 of x. So now if I look at number 2, y equals log base 3 of x minus 2. What is my replacement?
X with an x minus 2.
And what does that do to the graph?
Translates it 2 units, right?
Translate to right. So if I translate this 2 units to the right, it means if I take my original graph, what would I do with that original graph? Which coordinates would I move, the x's or the y's?
The x.
The x's. So I would take all the x coordinates and move them 2 units to the right. So 1 and 0 would become 3 and 0. This point here, which was 3 and 1, would become 5 and 1. The point here that was at 9 and 2 would become 11 and 2, which pulls it off the grid. So this is my y equals log base 3 of x minus 2. Now if we look at the last question, what was my replacement on 3? What did I replace?
Y with y plus 2.
Y with a y plus 2. And what does that do to the graph?
Translates it 2 units down.
Which coordinates get translated, the x's or the y's?
Y.
The y's. So I take all those y coordinates and I move them 2 units down. So this y coordinate at 0 moves down to 2. The y coordinate that was 1 moves down to negative 1. The y coordinate that was 2 now moves down to 0. So then my graph looks something like that. And there's my y equals log base 3 of x minus 2. Did any of these graphs impact the domain of the function? Change what the domain would be equal to?
No.
So if I look at 4, is the domain all the possible x values? Okay. What about the green one? Am I going to have x values in through here? Why not, Addison?
It shifts it 2 units right,
Moving's
so it
over,
starts.
so.
Because where's my asymptote? It's right here. So if I shift this whole graph over 2 units, where does my asymptote go?
2 units right.
Right here. So does that impact the domain? Yeah. And remember what we said, we can't take the log of a negative number. So anything less than 2 is going to make this a negative number. And what about the graph in red? Does the domain become impacted with that? Does moving the graph up or down change where the asymptote is going to be? No. Okay? Because it's my asymptote that basically is affected. So do any of these result in a change in the original domain or range? No for the first one. Yes for the second one. And no for the third one. So what is the asymptote of the first graph, the one that I drew in blue?
X equals 0.
X is equal to 0. What about the graph in green? X is equal to 2. And the one in red?
X equals 0.
X is equal to 0 again. Last question. One of the laws of logarithms says that log of x to the power of n is equal to n times log x. So the question is, are the graphs identical? So in order to state yes or no, the graphs are identical, we're going to consider even and odd values for n. So we're going to look at our even values. And by even values, what I mean is, let's say I let n equal 2. What I have is I have log x squared and 2 times log x. So that's what we're going to graph. So my window settings, I know I can start at negative 1 will allow me to see the y-axis. And go to 8. My minimum values, I haven't changed in a while. My minimums, I could go from like -3 to, I don't know, 15. Go up by 5s. Actually, no, let's change this. Instead of 15, change this to 100. And then go up by 10s. And to make it easier, we're not going to worry about the base, because the base probably, like if we look at everything that we've done, the base affects kind of how much it rises or the shallowness, but it doesn't really impact the general shape of the graph. So when we go to graph this, we're going to use the log button. So we're going to start off by graphing log x squared. And the x squared is in brackets. If I press graph, I did put it too high. Okay, we need to change our window settings. Let's go from -5 to +5. And then let's go from from negative 10 to positive 10. Should have just done a zoom normal. Now let's graph this. So we get this graph. The only thing I want to check is, does it actually join in the middle? So I could zoom in. Is it joining in the middle, or is each side going to just approach that y-axis? So what I did is I pressed zoom decimal. So I can start off with, there's my zoom normal, or my zoom standard. And then I change this to zoom decimal. And then I see a little bit better of the graph. So what I end up with is I end up with this graph that is actually on both sides. That looks like this and like that. And then if I look at what is log 2x, or sorry, 2 log x. 2 log x. Oops. What do you notice about that graph? What can you tell me about that graph?
It just has like the one side.
It just has the right-hand side, okay? So let's try the same thing if n is equal to 4. So then I have log x to the power of 4 and 4 log x. And do the same thing if n equals 6. So log x squared and 6 log x. So I'll give you a couple of moments to graph those 4 and sketch them. Okay, so what do you see about, what does the graph of log x to the power of 4 look like?
Because there's no the same as log x to the power 2, just log.
Okay, so I have 2 branches on either side. And what about 4 log x?
It's just the right branch.
And then the log x squared, or sorry, x to the power of 6?
Both sides.
Both sides. And then I have the one side. So when the value of n is even, are the graphs identical? Okay, let's check when they're odd. So again, I'll give you a couple of moments, and I want you to figure out if n equals 3, 5, and 7. So log x cubed, log x to the power of 5, and log x to the power of 7. 3 log x, 5 log x, and 7 log x. So what can you tell me about the graph of log x cubed and the graph of 3 log x?
They're the same.
They're the same. And are they on both sides, or are they just the one
Just
side?
on the one side.
Other.
And what about log x to the power of 5 and 5 log x?
The same thing.
The same thing?
You would have got
So to answer the question, are the graphs identical? How would we answer it? How would we answer the question, are the graphs of y equals log x to the power of n and y equals n times log x identical? What would you say?
if the value of n is odd, then they're identical.
two sides to them?
Because you could have negative or positive numbers, because they both end up being positive.
Because they both what?
Like they both end up being positive.
If I have x being a -3, when I put it into the equation, what does it become? +9. And I can take the log of +9. Can I take the log of -3? No. That's why on these graphs and all of these, there are no negative log values because, or sorry, there are no negative x values because I can't take the log of a negative number. But with these three, because the exponent happens before the calculation, those negatives become a positive value. Okay, so the questions that I want to add are 6,
What did you do?
8, 9, 10, and 12 to 17.
Did you tell me?
I'm so confused.
She didn't talk.
All fun cake. I know.
And now that you guys have handed in the Chapter 7 review, I can give you the Chapter 3 review. I think you either need different friends, Evan, or
Yeah.
a better eraser.
Yeah.
I'm going to assume
Yes to
that you
both.
would not actually sign your name that way. Just a thought. Something not very nice.
I erased it all up. I wasn't really sure. I didn't draw it, so I didn't really care.